roots theorem, section 3.6. Some polynomial functions are hard to factor, therefore finding x-intercepts can be hard, and this theorem will help. Any rational root of a polynomial function with integer coefficients is of the form x equal p over q, where p is a divisor of the constant and q is a positive divisor of the leading coefficient. Leading coefficient means the highest coefficient of the highest power of x. Example, sketch the graph of f of x equal 2x cubed minus 7x squared plus 4x plus 3. Divisors of the constant, a divisor of 3, that would be p, plus or minus 1, or plus or minus 3. And the positive divisor of the leading coefficient, that's 2, the leading coefficient is 2, and the numbers that go in, positive divisors of 2 would be 1 and 2. And then the possible rational roots, rational means fraction, is going to be p over q. So if we divide plus or minus 1 by 1, we'll get plus or minus 1. Plus or minus 3 divided by 1 gives us plus or minus 3. Plus or minus 1 divided by 2 gives us plus or minus a half. Plus or minus 3 divided by 2 gives us plus or minus 3 halves. So any rational root will be one of those. A rational means fraction. Okay, so that sort of narrows down our possibilities. We still have a rather long list of possible rational roots. So once we have our list, we can go through our list and check each one using, and the quickest way of doing that is usually with synthetic division. When you divide by x minus a, the remainder is the same as f of a. So if we get remainder 0, then that means that's going to be one of our x-intercepts. Okay, so I'm just going these through the list as it was written. Sometimes if you have some intuition about where the rational root might be, you don't necessarily have to take these in order. You can try a root that you think is more likely. I'm just going to take these in order. So I'm writing the coefficients of the original polynomial on top, 2, negative 7, 4, 3. I'll start dividing by x minus 1, so I'm writing a 1 here. Bring down to 2. 2 times 1 is 2. Minus 7 plus 2 is negative 5. So you just multiply, add, multiply, add. Negative 5 times 1 is negative 5. 4 plus negative 5 is negative 1. Negative 1 times 1 is negative 1. 3 plus negative 1 is 2. So that didn't work. So 1 is not going to be a rational root. That also tells us that f of 1 is going to equal 2. And we're looking for f of something that equals 0. So you go through each of these, and I'm not going to go through all of them, but the one that works is 3 halves. Bring down to 2. 2 times 3 halves is 3. The 2's will cancel. Negative 7 plus 3 is negative 4. Negative 4 times 2 halves is negative 12 halves, which reduces to negative 6. 4 plus negative 6 is negative 2. Negative 2 times 3 halves is negative 3. The 2's will cancel. 3 minus 3 is 0. So that's the one that will give a remainder 0. And then, so 3 halves is one of our roots. So that means that if you put the x's back in, either x equals 3 halves or 2x squared minus 4x minus 2 equals 0. So that's the answer from our division. We have 2x squared minus 4x minus 2. So either x equals 3 halves or 2x squared minus 4x minus 2 equals 0. We could, there's a couple of ways of proceeding from here. We could start where we left off and continue to look for rational roots. And we first of all we could check to see if 3 halves is a double root, and starting with the coefficients of our quadratic equation here, 2 minus 4 minus 2, to see if it's a double root. Bring down to 2. 2 times 3 halves is 3. The 2's will cancel. Negative 4 plus 3 is negative 1. Negative 1 times 3 halves is should be negative 3 halves. Negative 3 halves. negative 2 is the same as negative 4 halves. Negative 4 halves plus negative 3 halves is negative 7 halves. So that does not work. And then we could try negative 3. The only other number we haven't tried is negative 3 halves, so that's the only one left. Bring down the 2. 2 times negative 3 halves is negative 3. The 2's will cancel. Negative 4 plus negative 3 is negative 7. Negative 7 times negative 3 halves is 21 halves. Negative 2 is the same as negative 4 halves. Negative 4 halves plus 21 halves is 17 halves. So that doesn't work. So the other way of doing it is to use the quadratic formula. So x equals 3 halves, or 2x squared minus 4x minus 2 equals 0. A is the coefficient of x squared, which is 2. B is the coefficient of x, which is negative 4. C is the number by itself, which is negative 2. Plug into the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac over 2a. Replace b by negative 4. That's negative 4. B squared, negative 4 quantity squared. 4 times a times c is 4 times 2 times negative 2. Double negative is positive. Negative 4 quantity squared is 16. Negative 4 times 2 times negative 2 is also positive 16. 16 plus 16 is the same as 16 times 2. And as long as there's not more than one minus sign, the square root of the product is the product of the square root. So we can write this as square root of 16 times square root of 2. Square root of 16 is 4. And then distribute the denominator. 4 over 4 plus or minus 4 root 2 over 4. 4 divided by 4 is 1. 4 root 2 over 4 is root 2. The 4's will cancel. So I have 1 plus or minus root 2. So it's 1 minus, and by trial and error we estimate root 2 to be about 1.4. 1 minus 1.4 is negative 0.4. 1 plus 1.4 is a positive 2.4. So that gives us the x-intercept, and then we can plot points and sketch the graph. So again, we want to pick points on either side of our x-intercept. So I have x-intercept negative 4 and y is 0, 3 halves and y is 0, about 2.4 and y is 0. So pick points on either sides of those, and some of these values we've already computed using our results from our long division. If I can find those. So when we put negative 1 into our synthetic division, we got negative 10. So f of negative 1 is negative 10. So we don't even have to plug in to the formula for that. F of 0 we'll have to compute. That turns out to be 3. F of 1, we can use the result from our long division. F of 1 is 2. We got remainder 2 there. F of 2 is negative 1. We have to compute that. That was not one of the ones we computed. F of 3, we already computed with the synthetic division. F of 3 is 6. So the even though those did not turn out to be zeros, they were still, the computation was not wasted. We can still use that information to make the graph. So and then plot the points, connect the dots. Again, this is there's 2 humps here. I have 1 hump here, 1 hump down here. In general, if you start with degree 3, you'll have up to 2 humps, no more than 2 humps, but sometimes the humps flatten out. And that concludes this presentation.